Hello everyone. In this video, we will define an important notion called linear combination of vectors. Let me start with the definition. Assume that we have k vectors with n components. So v1, v2, vk are vectors from Rn. Then a linear combination is a vector. So a linear combinations of v1, v2 up to vk is a vector of the form you multiply the first by a scalar, the second one by another scalar, the third one by another, and so on, the kth one with another scalar, and then add all of these vectors. Then you get a vector. That vector is called a linear combination of v1 up to vk. Well, here, as I said, c1, c2, and ck are just real numbers, or some real numbers that we use to form this linear combination. What you need to know is that linear combination is basically the only thing that we can do with few vectors to generate a new vector in general space Rn. So you just multiply them by scalars and then add them to form new vector. Let's do some examples. Here we have vector w, 2 and negative 1, and the question asks to write this as linear combinations of v1 and v2. So basically what we are looking for are two constants, c1 and c2, such that w is c1 v1 plus c2 v2. Well, let's just write this in the form of vectors. So w is 2, negative 1, c1 times 1, 3, and c2 times negative 1 and 2. Then, left hand side is 2, negative 1. The right hand side, you multiply c1 inside, c2 inside, and then you add those two vectors, you get one vector. Now, I want to write this as two equations. So first component equal to the first component, second component equal to the second component. Now, see, if I multiply the first equation by 2 and add that to the second equation, this will give me 5c1 plus 0c2 equals to 3. Well, that means that we have found c1, which is 3 over 5. Now, I take that 3 over 5 and plug it into the first equation. So 3 over 5 minus c2 is equal to 2. That means that c2 is going to be 3 over 5 minus 2, which is equal to a negative 7 over 5. Yes, now we found two constants, c1, c2, such that w is c1, which is 3 over 5, times v1 plus negative 7 over 5, or just I'll write it as minus 7 over 5 v2. And that's how we write w as linear combinations of v1, v2. Yes. So this same example can be considered for a bigger number of vectors. For example, in this other example, I have w, which has 3 components, and I have 3 other vectors, v1, v2, v3, and we are looking for writing this as linear combinations of v1, v2, v3. Note that v3 has some complex numbers in it? Well, the story goes the same way. So we are looking for, this time, three constants, C1, C2, C3, such that W is C1 V1 plus C2 V2 plus C3 V3. Well, if I write this in terms of vectors, the left hand side is 2, 1, negative 1. Right hand side is, well, right, multiply C1 to the V1, you get C1, negative C1, and 0. And then you multiply C2 to V2, you get C2, 0, and C2 at the third component. And multiply C3 to the vector V3. There is 0 in the first component. Second component will be I C3. The last component will be 0 plus 0. So you add those ones, and then now I can write these ones as equations. So the last one tells me C2 is negative 1. The second component tells me that negative C1 plus IC3 is equal to 1. And the first component tells me that C1 plus C2 is equal to 0. Well, note that C1, the last equation, is basically telling me what is C2, the value of C2. I can plug in value of C2 in the first equation, and I find that C1 must be 1. Now I have C1, I plug it into the second equation, and I get a value of C3, which in this case is IC3 is equal to 2. That means that C3 is equal 2 over I. Well, 1 over I is the same thing as negative I, because when you multiply I to negative I, you get 1. So that means that C3 is negative 2I. And again, well, we found the proper constant. W is 1 times V1 plus negative 1 times V2 plus negative 2I times V3. And then this is V1 minus 2V2 minus 2IV3. Okay. Yeah. Well, this examples can go ahead and do different things, but specifically we are interested in writing a vector as linear combinations of eigenvectors of a matrix. Here the vector is 1, 0. The matrix is 1, 1, and 1, 2. So write 1, 0 as linear combinations of eigenvectors of the matrix. Well, what are eigenvectors? Well, actually we found eigenvalues and eigenvectors of this matrix in the video called More Examples for Eigenvalues and Eigenvectors. And over there we saw that there are two eigenvalues. Lambda 1 is 3 plus root 5 over 2. Lambda 2 is 3 minus root 5 over 2. Then V1, the eigenvector or an eigenvector for W1 is 2 V1 is 2 and 1 plus root 5. And an eigenvector for lambda 2 is 2 and 1 minus root 5. Now I want to write 1, 0 as linear combinations of those ones. Yeah, those are the eigenvectors. So 1, 0 must be equal to C1 times V1. V1 is 1 and 1 plus root 5. And C2 times V2, which is 2 and 1 minus root 5. Then write this as equation. The first component times added to the first component. So C1 times 2, C2 times 2, you get 2C1 plus 2C2 is equal to 1. Yes, that's the 1. And if you multiply the coefficients to the second component, you get C1 plus times 1 plus root 5 plus C2 times 1 minus root 5 must be equal to the second component of the left hand side, which is 0. Okay, how do you solve this? Then here I will use the first equation to write C1 in terms of C2. So C1 here is half minus C2. I take that to the other side divided by 2. Now I plug that into the second equation and I get what? Half minus C2 times 1 plus root 5 plus C2 times 1 minus root 5. This must be equal to 0. So let's just multiply this inside, expand this. What do we get here? Okay, so first gather all C2s and put on the other side the constant. There will be only one constant when you multiply half to 1 plus root 5. The other parts will be all multiple of C2. So we are going to have 1 plus... yes, so minus C2 multiply 1 plus root 5 is minus 1 minus root 5 plus 1 minus root 5. That's what we get there. So 1 and negative 1 cancel. So C2 times 2, negative 2 root 5 is equal to negative half 1 plus root 5. Then, okay, we go ahead and divide that coefficient of C2 to the other side. Negative 2 root 5 will go to the denominator. You get 4 root 5. And in the numerator, you have 1 plus root 5. So what we showed here is that 1, 0 is linear combinations of eigenvectors of this matrix. The coefficient for V1 is, I need to find C1. Yes, I have C2. Now I plug it in the equation that I wrote C1 in terms of C2. And that's what we get there. So then, well, I won't simplify. You can simplify that, but I will leave it like that. So that's C1 times 2, 1 plus root 5, plus C2, which is 1 plus root 5 over 4 root 5, multiplied to 2, and 1 minus root 5. Okay? So that's what we need to know. So what is linear combination, and how we can write a vector as linear combinations of other vectors, in particular eigenvectors of a matrix.